Okay, hi all. Today we want to talk about something else in geometry. We're going to talk a tiny bit about polygons and more so about quadrilaterals. So we'll get to polygons generally in a moment, but quadrilaterals, what are they? They're just a shape with four sides. Okay, so their four sides are straight lines and they create a shape. Now they can be regular like the ones we're used to, like squares or rectangles or parallelograms. Or they can be more unusual, like this shape that I've drawn here. This is also quadrilateral. It's got 1, 2, 3, 4 sides. Okay. Now, when we're naming quadrilaterals, just like triangles, we use capital letters normally: A, B, C, D, and we put the capital letters at each vertex. So just in case we've forgotten about vertex and vertices, this is a vertex where the point, I guess, that you make where two lines come together, or line segments come together. And the plural of vertex is vertices. So a quadrilateral has 1, 2, 3, 4 vertices. Now, when we're naming these quadrilaterals, we can call this the quadrilateral ABCD, just like we used to have like the triangle DEF or the triangle ABC. This is the quadrilateral ABCD. But where you start doesn't matter. You could also call this the quadrilateral DABC or the quadrilateral CDAB. Or indeed, even though we tend to go anti-clockwise quite often in maths, if you called it the quadrilateral ADCB, that would be equally correct. That would be fine also. So that's how we name it. The next thing, I suppose, generally about quadrilaterals is that whether they're unusual like this or the more regular ones, there are a few things that they have in common. Specifically, I want to name two of them. One of them is that they have four sides which are straight lines. Sometimes they're the same length, sometimes they're not, like this. And also, and this may be new to us, all of the angles inside a quadrilateral, so the angle here and here and here and here, they always sum to 360 degrees. They always add up to 360 degrees. So I'm just going to say angles sum to 360 degrees. Now we have a nice simple way of showing this as well, and that is with a little construction here. If I draw the diagonal of a quadrilateral, so in other words, if I draw the line joining opposite vertices, so this B and D are opposite vertices, if I draw a line joining those two, it always divides a quadrilateral into two triangles. And we know that the angles in a triangle sum to 180 degrees. So this angle plus this angle plus this angle add up to 180 degrees. And in this triangle here, also the three angles sum to 180 degrees. So this angle plus this angle plus this angle sum to 180 degrees. So 180 and 180 is 360 degrees in this quadrilateral. So this plus these two together plus this plus these two together sum to 360 degrees. And we can see the same thing in all quadrilaterals. If I just do a quick sketch of a rough square there, again, if I draw the diagonal, always two triangles are formed, 180 degrees and 180 degrees, 360 degrees. So moving on from the quadrilateral then, polygons generally are any shapes which have straight lines as their sides, and they must have either three or more sides. So for instance, a quadrilateral is a polygon, a triangle is a polygon, square is a polygon, and we're used to a lot of types of polygons. Now this isn't the greatest sketch in the world, but we can see this is supposed to be a pentagon, so this would be known as a regular polygon, as would a square. This would be irregular. And here we have a hexagon, a regular hexagon. It has 1, 2, 3, 4, 5, 6 sides. So these are all polygons. So polygons are, shapes with straight lines as their sides, can be regular or irregular, must have three or more sides. Okay, so one other thing then about other polygons like this, and in particular the regular ones, the ones that have sides which are all the same length. We're often asked in maths to show or to find out what the size of the angle is in these in these regular polygons. So when I say the size of the angle, just the size of one angle, because they're regular, they have same length sides and equal size angles. Same goes for this hexagon. All the sides are equal in length and all the angles are equal in measure. So again, using a similar method to what we used above here, using triangles, we can figure this out, and we can do it for any type of polygon, any number of sides. So what we do is we just draw straight lines to divide our shape into triangles. So if I draw this from here to here, I've got one triangle and I've got 1, 2, 3, 4, a four-sided figure, a quadrilateral. So I must draw another line here. If I draw that now, you can see I've got 1, 2, 3 triangles here. Now I know that each triangle, the angles in it add up to 180 degrees. And so if I add them together, 180 plus 180 plus 180 is what? 360, 460, 540, 540 degrees, we'll say, in this pentagon. Well, if there are 1, 2, 3, 4, 5 angles in the pentagon and they're all equal in measure, then if I divide this by 5, I should be able to work out what the angle in a pentagon is, or the measure of an angle in a pentagon. So 5 into that is 1, 0, 5 eighths are 40, 108 degrees is each of these angles in the pentagon is 108 degrees. And we could do the very same thing for our hexagon here. All we have to do is again divide it into triangles. So whatever way we can, that's one triangle, 2 triangles, 3 triangles and 4 triangles. So 1, 2, 3, 4. We know each of them is 180 degrees. So I could say 180 multiplied by 4 first of all. 2, 3 is 720 degrees altogether. So I guess 360 and 360 is 720. And I know now that each of these angles is equal in measure, and there are 1, 2, 3, 4, 5, 6 of them. So if I divide this by 6, 6 12s are 72, so it's 120 degrees each of these angles is. And you know, it makes sense. I'd always have a look at it to see. Now my drawing isn't great, but you can see from the drawing that it does look like an obtuse angle in each case, an angle which is greater than 90 degrees.